Today we're going to get into writing equations and real-world applications and learning how to use them. I'm going to write our favorite equation up at the top of the page. Y equals mx plus b. And you know what? You can also write it like this. Mx plus b equals y. That's a linear equation. You graphed them in Unit 5. You learned how to write them in Unit 6, and now you're using that in a word problem. Let's look at the actual problem. It says, let Y represent the total cost of publishing a book in dollars, and X represents the number of copies of the book printed. Suppose that X and Y are related by the equation 15X plus 1150 equals Y. What that means is, look at that equation and identify the parts. Well, that is the M and that is the B. Remember, the X is not part of the slope. The X is where your input value goes. Now we're going to answer the questions. What is the change in total cost for each book printed? Well, that would be what is the rate of change. Look at the equation. Which number is affected by an increase of books printed? The M, 15. The M value, which is the slope. Now, what is the cost to get started before any books are printed? That would be the Y value, the Y-intercept, which is the B value, $1,150. It costs $1,150 to get all the machinery and buy all the paper before a book is printed. So if we were to graph it, that point would be 0, 1150. Now you've learned and you've heard that the X value influences the Y value, so now we're going to do something with that. We're going to talk about independent and dependent variables. Independent variables will cause change, the X input. Dependent variables rely on something else, the Y input. So if you ever play with Play-Doh, you put the Play-Doh in the top, that's the X. Whatever comes out the end, that's your Y. Now let's figure them out. A function relates the input K to the output M equals 5K minus 3. What is the dependent variable? Well, we've got some key words here. We have input K. And then we have the output equation. So the dependent variable is the one that relies on the input variable. So M is the dependent variable. M, dependent. It does not change what happens to K. K changes what happens to M. K changes M. There we go. Alrighty, let's do another one. You've got a used car dealer examining how the price at which a car can be sold varies with the car's mileage. Which is the dependent relationship? Well, I'm going to have you ask yourself two questions. Does price, not Prince, does price influence car's mileage? Or does the car's mileage influence the price? I think you know that the car's mileage influences the price. So the mileage is the independent variable and the price is dependent. Price depends on mileage. And let's think about it logically. If you are going to buy spend $3,000 on a car, does that change the mileage on any car you look at? No. Next one. The amount of a certain medication taken in the morning influences the amount of sleep that night, which is independent. I'm going to write the two questions again. Does medication influence sleep, or does sleep influence the medication? Well, the amount of medication influences the sleep. So the medication is independent. There's page 1. Now on this second page, we're going to link independent variables and dependent variables to domain and range. You learned about domain and range back in Unit 5, and I'm going to draw you a little chart at the top, and this is how you're going to keep things together. We have domain, and we know the coordinates from the domain are the x-coordinates. Now, in your standard y equals mx plus b equation, which I'll write up here like I always do, your x value influences the y. So this is independent. Now let's look at the range. Those are your y values, and they are dependent. I want you to get all those things lined up and get them solid in your head. So let's talk about the Sugar Sweet Company. Delivers sugar. C is the total cost to transport sugar. S is the amount of sugar transported in tons. And the company can transport up to 20 tons of sugar. And here is our equation. Gives C as a function of x. That means S determines C. Now we're going to identify the correct description of the values in domain and range, and then choose the set. So let's talk about that. Domain is that the cost to transport sugar or the amount of sugar transported. That is the amount of sugar transported, because that helps determine the cost. Now the set of all values, this is where you have to really read the words. Now, let's think about this logically. What is the least amount of sugar you can transport? Least amount is 0. 0 tons of sugar. And what's the most amount of sugar you can transport? Well, it says up in the words, 20 tons. 20 tons. So what you're looking for is the set of all values. Well, let's see. If the least amount we could transport is 0, that gets rid of that one, that gets rid of that one, and that gets rid of that one. The most we can transport is 20 tons. That eliminates that one. So this is the correct set of values. Now let's look at the range. Well, if you get domain right, you're going to get range right, because range is the other one. The range is the output, the cost to transport the sugar. Now the least amount of sugar transported is 0 tons. So the lowest cost is what you get when you plug in 0. For 0 tons of sugar, that's $1,500, probably truck maintenance. So let's just stop right there. Well, it's not going to cost 0 because there are startup costs. If the lowest cost is $1,500, I'm just going to eliminate everything. The set of all real numbers from 0 to 20 is the amount of sugar you can transport. That is not the cost. So the set of all real numbers from 1,500 to 3,900, this is it. So the least amount influences the lowest cost. And by math, you find out that the highest cost is $3,900. But if you focus on the least, you can probably get that answer right. All right? So look at the words carefully. Every bit of information you need is in the description as well as the equation.